right, so we're going to match this in behavior. Okay, so what did y'all come up with? What did y'all come up with? Which in behavior goes with which one? Okay, solid. Nothing. You shall not write it down. What'd you come up with? 2 to the x plus 3. What about that one? It's the second one. You're saying is this one? Okay, so let's look at it. So as we're standing here, as we look to the right, what's happening to our y values? They're going up. Okay, so that's good so far. All right, let's look to the left. As we're looking to the left, as x is approaching negative infinity, what's happening to our y values? Where are they getting closer and closer to? 3. Okay, so that's right. So this guy matches with this guy. And then let's look at the other one just to kind of talk about it. If we're standing right here and we look to the right, what's happening to our y values? They're getting bigger and bigger, right? As we look to the left, it's getting closer and closer to 3, and our y values are going to negative infinity, right? Okay, so that's why this matches this one, and that one matches that one. Okay, so today we're going to be looking at graphing exponential and logarithmic functions. So go ahead and take a second and write down the following. Go ahead and take a second, write down the following. Okay, so let's actually look at this. We've got transformation comparison. So we're looking at an exponential, and then we're also looking at the logs. Okay, so when we go into an exponential, so let's take like 2 to the x, for example, and we put up here x plus 4. Where did that move it? Where did that move that original function? To the left, right? Okay, so H is going to deal with our left and right. Okay. Now let's look at a log. Let's try that one. Okay, so if we come in here and we hit this little key, we go to functions, we scroll down, and we type a log of base 2 of x plus 4. Well, let's start with log of base 2 of x. What did that do to the equation when I put plus 4? It moved it left, right? Okay, so one thing I want you to note on here is that it's the opposite of the sign. Okay, and what I mean by that is since we put plus 4, it moved left. Normally you think right, right? All right, so now let's look at our k. So coming back up here, if I put plus 6, where did that move it? It moved it up, right? Okay, so k is going to deal with moving up or down. Same thing's going to happen with our logs. Okay, what if a is negative? Okay, well, let's look at it. If I take a and I make it negative, let's put a -2 out front. What did that do to the function? So here it is again. Here was the original. What did a -2 do to that function? It reflected over which axis? Okay, reflected over the x-axis. Okay, now if we change our a value, let's make it we make it bigger or we make it smaller, what's the difference? Well, let's look at the comparison. Okay, so what does it do? It's farther away from the y-intercept, so did we stretch it or did we compress it? The green one, we stretched it. The red one, we compressed it, right? Okay, so if A is in between 0 and 1, there is a compression, or we're going to say shrink. You're going to see both of those words. If A is bigger than 1, then we're going to see a stretch. All right, so looking at this problem, we're going to go and type it into Desmos. Okay, so we've got 3 raised to the x minus 6. And remember, when you type this into Desmos, you got to use those parentheses. Okay, and so we see that graph right here. Now, domain. Okay, remember, domain is going to deal with our x values. Okay, so how far left do we go? Well, it keeps going on forever, right? So we're going to represent that by negative infinity. How far right does our x values go? Well, they just keep going, right? If I look at my table from my Desmos, I could just keep typing in multiple numbers and it would keep producing some y value. That's how I know my domain keeps going on forever and ever. Okay. So we're going to represent this by positive infinity. For our range is our lowest y value. Okay. So you see how there is a horizontal asymptote right here. Okay. It kind of levels off. It gets close to a certain number, but never actually touches. So an asymptote is something that we get really close to, but never touch. Okay, so what's that number that it gets really close to? 1, right? And we can see that from our equation. You can see that right here. Okay, so our range is going to be from 1 to positive infinity. Okay, and notice how I use parentheses and not brackets, because it never actually touches 1. Okay, for exponential, we're going to have a horizontal asymptote. And just like we just talked about, this number out here is normally going to be your horizontal asymptote. So 1. So we're going to write that out as y equals 1. Our x-intercepts, well, it never crosses the x-axis. So we're just going to put none. And please don't put 0 on that. I had a couple people on the last quiz put 0. Okay. Our y-intercept is where it crosses the y-axis. And they already filled it in for us. That's 0, 1.001. And you can find that by looking at your table and seeing when x is 0, what's your y. All right, our in behavior. I know we struggle with this one, so pay attention. As x is going to the left, so as x approaches negative infinity, what happens to our y values? Where are our y values approaching? Well, they're getting closer and closer to 1, right? As we move to the right, as x approaches positive infinity, what's happening to our y values? Well, it's going up and up and up and up. So that's going to be positive infinity. Okay, so now that I've done one for you, I want you to try this next one. Okay, so this next one is 3 raised to the x minus 1 plus 6. Okay, and I'll scroll down in just a second, but you're going to do the same thing. You're going to find the domain, range, asymptote, x and y intercepts, and then in behavior. Okay, so take about 2 minutes, try that, and then we'll come back. All right, so let's check over your work. So for domain, most of the time your exponential, unless it's like a word problem, is going to be from negative infinity to positive infinity. Your range is going to be from 6 to positive infinity, because our lowest y value is 6, our highest y value is infinity. Your horizontal asymptote is y equals 6. There's no x-intercepts because it doesn't cross the x-axis. Your y-intercept is where it crosses the y-axis. Now, I couldn't really tell what this was, so I went in and I typed this into Desmos, and I looked at when x is 0, what's my y? And then my in behavior is as x approaches negative infinity, what's happening to my y values? They're getting closer and closer to 6. And as x approaches positive infinity, what's happening to my y values? It's approaching positive infinity. Okay. Are there any questions on this one? How do we do on it? Pretty good? Okay. All right, so the next one that we're going to work on is logarithmic. So this is kind of similar, but you're going to have a different asymptote. So I'm going to go ahead and type this into my Desmos just in case. So when I type this into Desmos, I'm going to go to functions. I'm going to scroll down. Oh, this isn't showing. Oh, yeah, there it is. Okay. So all the way down to calculus and then that log of base A. All right, so when I type that in, I'm going to get log of base 3 of x minus 6, close parentheses, plus 1. You got to make sure that when you're doing your exponential or you're doing log, that you make sure that you use your parentheses. Okay, so all right, so looking at this over here, we've got our domain. Now with logs, we're going to have a vertical asymptote. We're not going to have a horizontal asymptote. So that's one thing that we got to remember. So for our domain, it goes from right here all the way over. Well, what's this value right here? Well, if we're unsure, remember, we can go into Desmos and we can look at where this line is. Well, that's roughly about 6, right? Well, looking at our equation, we can see that 6 is right here. Whatever number is right here, that's normally going to be our vertical asymptote. Okay, so our vertical asymptote is x equals 6, and we're going from 6 to positive infinity. So we went from 6 to positive infinity. For our range, we're going to go to our lowest y value. For our lowest y value is negative infinity. And what's our highest y value? Well, it continues up. So that's going to be positive infinity. Okay. So now looking at our graph, we're going to look at our x-intercepts. I'm not sure why they have not come to it. For our x-intercept, it's where it's going to cross the x-axis. Okay, so when y equals 0, what does x equal? Okay, this one's kind of hard to tell, but it's this dot right here. If you're ever unsure, I would go into Desmos and then click on this little dot that crosses the x-axis. So that's going to be 6.33, 0. So that's going to be 6.333, 0. And we don't have any y-intercepts. For our in behavior, we're going to go as x approaches the left. So instead of saying as x approaches negative infinity, remember we have that vertical asymptote. So we're going to say as x approaches 6, what's happening to our y values? Where are they going? To negative infinity. As x approaches positive infinity, what's happening to our y values? They're going up to positive infinity. So I want you to take a second and I want you to try this one. Log of base 3 of x plus 6 minus 1. Okay, so you're going to try that one, doing the domain, range, the whole. All right, so checking over your work, you should have gotten for domain negative 6 to positive infinity. For range, you should have gotten negative infinity to positive infinity. Your vertical asymptote, remember, it's going to be this number, just change the sign, is going to be x equals negative 6. Your x-intercept, the way I found it is I plugged it into Desmos, and then I looked at where it crosses the x-axis right here. And then your y-intercept is 0,0.63. Again, I can find that by just clicking on that little button. My in behavior as x is approaching negative 6, remember that's my vertical asymptote, y is approaching negative infinity. Okay. As x approaches positive infinity, y is approaching positive infinity. Are there any questions over this one? What's up? Positive infinity going to positive infinity. Yep. Okay. All right, so I want us to get a little bit more practice on this. I know we're pretty comfortable with a couple of things on this, but we want to make sure that domain and range and in behavior are good. What's up, London? Girl. 0,0.63. Yep. All right. So coming down here, there's this. So when you open it, it's this little document. So you've got about 1, 2, 3, 4. It's 12. Okay, so you got about 12 different descriptions. What you're going to do with those 12 different descriptions is you're going to come down here and match it to one of these graphs. Okay. So you're going to probably have to open this document up on your own. One thing that I want you to make sure that you're paying attention to is that it says answers will repeat. So you may have a vertical asymptote with more than one function. Does that make sense? So like if it's a log, obviously it's a vertical asymptote, right? Okay, so you're going to take a couple minutes to work on this. You will be turning this in to me at the end of class. Okay, so before you leave, you're turning this in. Okay? All right.